In this video, we're going to talk about what's called Heron's formula, or sometimes Hero's formula. So Hero or Heron, whatever, we're not sure what his name is. There's a couple different versions of it. Was a Greek philosopher and mathematician who lived around 75 AD. So this is very, very old. It's what Heron came up with, or Hero came up with, is that the area of a triangle is given by the square root of s times s minus a times s minus b times s minus c, where the s is known as the, I'm going to try to slide this over if it will cooperate. So that's where S is called the semi-perimeter. So it's just you add up the three side lengths and divide by 2, and the A, B, and the C represent the side lengths themselves. So it works in any triangle, as you can see there. So the way that works is if we take a triangle that has side lengths, A is 43, and B is 53, and C is 72, then from our calculator we can get that the semi-perimeter, did I find that? Yes, S is going to be 84, and then plugging it into our formula, we should get that the area is going to be 1,131.887 to 3 decimal places. So it's just a matter of plugging it in. If we try another one, and this one, if we say that the side lengths are 14, 17, and 7, then I believe that our semi-perimeter is going to be 19. And plugging that into our formula, we should get 47.749. Okay, so remember that's going square root of, we have our semi-perimeter, and then 19 minus 14, and 19 minus 17, and 19 minus 7, and then plugging that in. Now we have some other formulas for a triangle as well. We're probably pretty familiar with the first one, that the area is 1/2 base times height. Another one that you may not be aware of is 1/2 times BC are the side lengths, and then sine of angle A, and then we talked about Heron's formula. So let's use this second formula right here on our triangle that we are shown. So in this case, we can say the area is going to be 1/2, and then we're going to do our side lengths, the 4 times the 7, and then it's the sine of that angle in between them, which in this case is 54 degrees. So if you plug that all into our calculator, make sure you're in degree mode, I believe we are going to get 11.326. Okay? And a few review problems, going back a little bit. So if you recall, when we have the inverse tangent, tangent of the inverse sine of x over 5, this is going to be the inverse sine of x over 5 is that angle in quadrant 1 whose sine, opposite over hypotenuse, is x over 5. We can do a little Pythagorean theorem and get that that's going to be 25 minus x squared. We then take the tangent of that angle, which is going to be from SOHCAHTOA, opposite over adjacent, and we're agreeing that we're not going to try to rationalize when we have variables in the radical in the denominator. Now the next one, this is, we want to see this is kind of a new twist on these problems. This is really the sine of the sum of two angles. So to do this, we need our formula for the sine of u plus v, which according to our formula sheet is going to be the sine of u times the cosine of v plus the cosine of u times the sine of v. So we're going to need to know the sine and the cosine of angle u and the sine and the cosine of angle v. So we can draw a reference triangle in quadrant 1 for each of those. We're calling this our angle U, so that's the angle whose cosine is adjacent over hypotenuse, and that's going to make the opposite side, using Pythagorean theorem, the square root of 1 minus x squared. V is going to be this angle whose tangent, opposite over adjacent, is 1, and using the Pythagorean theorem there is going to get us the hypotenuse is square root of 1 plus x squared. And really write that very clearly. There we go. So now, going back to our formula, we're going to get, so now we're looking here, so the sine of angle U is going to be the opposite, square root of 1 minus x squared over the hypotenuse, times the cosine of angle V, which now we're looking at the other one, that's going to be adjacent over the hypotenuse. And then we're going to say plus, and then the cosine of angle U is going to be the adjacent over the hypotenuse, times the sine of angle V, which is going to be x over the square root of 1 plus x squared. Conveniently enough, we have a common denominator of square root of 1 plus x squared, so we're going to add the numerators, which will be the square root of 1 minus x squared, and then plus an x squared, and though that is kind of messy, that is in fact our answer. Now, in a similar fashion, we're going to look at this as the cosine of 2 theta, or 2u. So then, looking at our formula sheet, we can see that we have a choice for cosine 2 theta. You can go cosine squared minus sine squared, or 2 cosine squared minus 1, or 1 minus 2 cosine squared. So I'm going to go, just for fun, the first one and call that the cosine squared theta minus sine squared theta. So then I'm going to draw our reference triangle. So our arc cosine of x is going to be the angle whose cosine is x, adjacent over hypotenuse. We'll use some Pythagorean theorem to get that opposite side. So then, using our formula, we're going to come down here and get cosine squared. So cosine is x over 1 squared, minus the sine is going to be the square root of 1 minus x squared over 1 squared. So that's going to be x squared minus, squaring that's going to remove the radical, and distributing that is going to give us a -1. Kind of crazy, huh? And the next one is, this is going to be another double angle formula. So we know that sine 2 theta is 2 sine theta cosine theta from our formula sheet. So our angle is the one that has a cosine of 3x. So we'll go adjacent over hypotenuse. We'll do some Pythagorean theorem to get the opposite side. And then we're going to use our formula and get 2 times the sine of theta, which is the opposite over the hypotenuse, times the cosine of theta, which is the adjacent, times the over the hypotenuse. So the 2 and the 3x will be 6x, and that is all over 1. So there we go. Excuse me. And that's the end of this one.